My name is Vas Mitra. I'm an SAP solutions architect at VMware. Been at VMware 4 years now doing SAP on VMware work. Prior to VMware, back in the 90s, I used to be an SAP admin in the East Coast. And my colleague?
Yeah, I'm Mohan Potteri, and I work for VMware PSO, and I work for the Business Critical Apps practice. And my previous background is virtualization admin, Unix admin for the past 20 years.
Okay, so the agenda for today, just a quick question before I start. How many people are running SAP on VMware, either production or non-production? Okay, that's a good amount. And I guess there might be some others who perhaps have SAP in your environment, but you haven't yet virtualized. So if you look at the agenda, we're going to cover sizing, how you size SAP on VMware. And that's kind of useful if you've not virtualized and you want to go to a virtualized scenario. So for those customers who haven't virtualized yet, that's hopefully should be useful. And for those of you who have virtualized and already running SAP in a VMware environment, you probably got a lot of knowledge already, but some of the stuff we're doing towards the end of this is like performance management and using vCenter operations for SAP. I'm going to cover that. That may be useful for you as well. So just kicking off with an introduction. SAP has supported VMware since 2008, late 2007 actually. SAP is a 3-tier architecture. So you've got presentation, application, database tier. All parts of that stack is fully supported on VMware. On the presentation tier, SAP has a traditional thick client called SAP GUI. That's supported on ThinApp. If you want to package that up on ThinApp, you can. And then on the application tier, they've got the NetWeaver middleware stack, which is SAP's middleware that consists of business processes running in ABAP, which is their 4GL. That's SAP proprietary 4GL. Their ABAP language is based on C. They also have a Java stack. The Java stack is predominantly used more for presentation to the GUI front end. If you don't want to use SAP GUI, but you want to use a web browser, a lot of the Java will handle that presentation. But the key thing to note is a lot of the core business processes that run in SAP, the big heavy jobs, batch jobs, a lot of the OLTP transactions, they run on the ABAP side. So it's the ABAP side that is heavy on workload resources. And Java as well, but some of the products may run Java, but the key big products, ERP, supply chain management, CRM, is ABAP based. The SAP portal is Java based. And then SAP acquired Business Objects a few years ago, and Business Objects is now part of SAP's main product set. I probably got the name wrong. They probably call it something else like Business Intelligence. But Business Objects is predominantly Java-based, their middleware. And a lot of the best practices for running Java on VMware, there's a separate session on that. They apply to the Business Object side. And on the database backend, the common databases we come across is SQL Server and Oracle, and then DB2. Now, recently, SAP, they own Sybase. Sybase is now supported to run in production, so you can run the SAP ERP system on Sybase on VMware. That's relatively new, so in the future we might see Sybase coming up to speed. Going forward, SAP's long-term roadmap is to add another component to the data layer. It's called HANA. That's their in-memory database. So they're looking to replace RDBMS in some cases with HANA in memory, so you can get very high performance. And HANA at the moment is not available. It's a physical appliance, but we are working with SAP to get HANA virtualized. So that's work we are doing with SAP. So watch out for possible announcements in the coming months on that. So I'm going to talk about sizing, just introduce what sizing is in SAP. So SAP has a metric called SAPs. SAPs is the SAP metric in which they do sizing and they run benchmarks. And it's equivalent to, you can say, one sales and distribution user is equivalent to 5 SAPs. So whenever they run a benchmark, they certify the benchmark and give it a value of SAPs. And as I said, it's based on the SD module, which is, so every time they do a performance rating, they normalize it against SAPs. That way you can compare the infrastructure between one hardware vendor to another hardware vendor. Now, when you size in physical, we've been doing it with SAPs for the last 10 plus years. then now you can still use SAPs to size on VMware, and we'll show you that in an example that Mohan will show after in the next couple of slides. So the idea is you collect all your business requirements, you figure out how many users you need, the type of modules they're running, and SAP have a way of converting all that business data into a SAPs requirement. So, and you can do that through a tool called SAP QuickSizer. So all your business requirements are then converted to SAPs. On the bottom right, on the infrastructure side, each hardware vendor has a SAPs rating for their servers. And you can, if you have a physical SAPs rating for your server, it might be something like this server can do, say, 9,000, 10,000 SAPs of work. Now, the VMware overhead for SAP is about 6 to 10%. So what we do for sizing on virtual, we take the physical rating and just take off 10%. So we might start off with 9,000, 10,000 SAPs, take off 10%, we end up with 8,000 SAPs, virtual SAPs for this x86 hardware. And then we match those SAPs up to the business requirements. And that's how you determine how much hardware you need. And we'll be showing that. So the idea is you can actually, from the virtual SAPs rating, you can get you can calculate the SAPs per vCPU. And I want to go into that in a bit. And I have to bring up hyperthreading, but before I do, I forgot, I'm going to show you this slide. We added this is the repeat session, but I'm adding it now because, as I said, a lot of benchmarking is done in SAPs. This is a 3-tier benchmark we did with a hardware vendor, and they ran a certified benchmark in a 3-tier scenario, which is the application was scaled across multiple virtual machines, 20 virtual machines, and then you had a 20 virtual CPU database VM, and they just ran their benchmark kit and kept adding users until they got a result of 32,000. That's a pretty high result. So a lot of customers who want to virtualize SAP, their SAPs requirements, their business workload requirements should fall well within this benchmark. So one of the greatest proof points of this is this just shows you can easily scale out app server VMs. Just scale out SAP application servers in virtual machines, same way as you do on physical. Just treat your virtual machine as a physical machine. And in the sizing, what we typically see, we typically pick virtual machine sizes for app servers between four-way, 8-way. It's typically what's common. A 4-way and 8-way app server is typically common what we see with our customers, but a lot of it depends on your individual workload requirements. And the advantage is when you're on VMware, of course, in the sizing scenario, we often overestimate our requirements because we have to. SAP is mission critical. We often size for peak workload, and typically then when you go live, the first 3 weeks of the month, you're not running at peak. You probably won't need all these app server VMs. So you just keep, when you don't need all those virtual machines, just keep them offline or just delete them if you don't need them, or recreate them as and when you need them from a template. And that's the advantage of going on VMware, especially on the app server tier. The databases tend to be a bit more static. DBAs will size the database, say for, in this case, 20 virtual CPU and kind of leave it at 20 virtual CPU. And then, but you do have the option, obviously, once you're on virtual, it's so easy to, if you get some downtime, just bring down the size of your VM if it's too large. We've seen a lot of customers virtualize the database now. For the last 2-3 years, and they've been speaking at VMworld and they're speaking at SAP conferences. Customers are virtualizing the complete stack. They tend to start with the application tier first in production because it's kind of the low-hanging fruit, and they have moved on to the database. So to give you an example, I've heard that one of our partners runs SAP internally, and they've virtualized SAP in production, and their database is up there around 20 to 25 virtual CPU. So we're seeing those proof points coming back to us now. I'm going to talk about hyperthreading because it impacts the sizing a bit. So just a quick question. How many of you are running hyperthreading in your current environment? That's about half. Anyone running without hyperthreading? Just, I assume, Optron. OK. So typically what we've seen is hyperthreading is very common in a lot of our SAP accounts. So I just want to go through the concept of hyperthreading and how it impacts our sizing. This is a test Performance Engineering did this a couple of years ago. And they were trying to validate the scalability of SAP in virtual machines with hyperthreading. So they did a test where they started off with a hyperthreaded box, 8 cores, 16 logical CPU. So with hyperthreading, each core presents itself as 2 logical CPUs, and they matched up the vCPUs to the cores in this first scenario. So they had 1 vCPU to 1 core, and by default, our scheduler, if you're not overcommitted on vCPUs, our scheduler will try and allocate a dedicated core for that vCPU. That's kind of the default behavior of our scheduler. And they scaled up, they had a database and multiple app servers, and they ran a workload, and they got 1,300 users about. Then what they did is they beefed up the number of vCPUs. The second test, they beefed up the number of vCPUs, so there was a vCPU for each logical CPU, for each thread. So 16 logical CPUs, 16 vCPUs. And then they started to increase the OLTP workload to see how much more throughput they could get, and they got a 24% increase. So this is pretty much in line with what we see with our hardware partners. For an SAP OLTP throughput, hyperthreading gives us about 20 to 30%. So in sizing, we'll use 25% for OLTP throughput. Batch jobs might be different, and we're going to come to that a bit later. So what we do is, when we size, do we size for the bottom scenario? Do we match vCPUs to threads, or do we match vCPUs to cores? We size, in fact, in the above scenario. For a basic sizing, which we do for a customer before they go live, we go very conservative. We assume we take your SAP's requirements and we allocate vCPUs so there's a one-to-one match, vCPU to core, and we basically ignore the benefit of hyperthreading. It gives us an additional buffer that we can use later on. Now, what that might mean is when you go live, you might see the environment is oversized. You might see utilizations really low because we've kind of allocated too much hardware, but typically customers then use DRS and vMotion to rebalance the workload to get better utilization. But we take this route because it's more conservative, and SAP is mission critical. So now I'm going to hand over to Mohan, who will go through a sizing example.
So one thing I wanted to add before I get started is that when you start virtualizing initially, you used to a lot of big consolidation ratios. And when you come to business critical apps like SAP, you got to be careful here. You have to, the ratios come down drastically. It could be 5:1, it could be 3:1, but that is the first thing I want you guys to start thinking about. It's not the traditional virtualization anymore. This is your important servers, this is your business critical servers. You want to give them the performance, because when you want to virtualize your business critical apps, the first thing you hear from your DBAs and your application owners is that, will it perform? So we don't want to do the same kind of a consolidation that we did for a tier 3 or tier 2 apps. So we want to, here I'm going to talk about an example that's actually based on a customer engagement that I had. It's a semiconductor company. And it is not a greenfield in the sense they're already running on Solaris. So we're going to take their Solaris environment and virtualize this on Linux. And so this kind of goes through, like, usually if you have a greenfield, you would have use the quick sizer, but here we already have a running environment. So we're going to use this SAPs that Vas was talking about, and that is kind of, we're going to calculate the SAPs that the current environment is using, and then we're going to use that to size the new virtual environment. And we can use a lot of ways, and here in this case, the customer used something called a SAP early watch report that gives you information on how much the servers are utilized. You could also use your own measurements on your Unix systems, or also use capacity planner. But in this case, we use the early watch reports. So the customer kind of gives this. Usually, the process that we follow is the customer has selected a hardware vendor. In this case, it's Dell. So they go to Dell and say, I need to be able to translate what I have in my Solaris environment to my Dell environment, to an x86 environment. So Dell would ask them the required information, in this case, early watch reports that Dell was provided. And Dell came up with, okay, this is your current utilization on your environment. And now we're going to use that information to fit you into an x86 environment. So one thing I want to talk about here is this customer, they have licensed their database, which is Oracle, based on processes. They didn't license. You can license databases for SAP in two different ways. One, you can buy the licenses through SAP. That is like a named user license. Or you can license it by processor. If you license it by processor, due to requirements that Oracle places that every node in the cluster has to be licensed, physical node in the cluster has to be licensed. If you run your app server and your database server on the same cluster, then you're gonna pay Oracle a lot more money for licensing. So in this case, what we did was, since they are licensed it by processor, we have to create a separate cluster for the database. And also, when you select a host to run SAP, you want to maximize it for the kind of things that are going to run. So for database, for example, we maximized it on a Dell server that is 32 cores because we got faster speeds on those machines. So you see that there are two different types of servers here that the customer would be using. The one above is like 62,000 SAPs, and the other bottom one is 70,000. That's because of the number of cores. So there's a big correlation, good correlation between SAPs and the CPU, the number of CPU a box has. And then based on the conservative nature of our sizing, we take the SAPs that the hardware vendor gives us, take out 10% out of it, and you come up with those numbers you see there. And then based on that, you then divide it by the number of cores that the box has, and you come up with a number for number of SAPs per core. So if you take this and then you look at the SAPs of a particular module, now you're able to say, okay, this module needs so much vCPU. So we're going to use this math to come up with the number of vCPU a particular module has. So the next slide, this is like an example of the customer and what their SAPs were, and then what the DB SAPs, and there's a DB SAPs component and an app SAPs component. And then we take that and then use the number of SAPs per core, and we come up with, for example, you look at the top, ECC is like 110,000, 80,000 app SAPs, and database SAPs 30,000. The database has to be a single instance because it's so because of that you can have only one database server, whereas in the app tier you can have multiple servers. So you see that there are 6 app server VMs with 8 vCPU each, and then there is one database VM with 16 vCPU. So by doing that, one thing that we have to keep in mind is sometimes you would cross NUMA boundaries. So in this case, the database server is an 8-core box, 8 cores per socket. So because of that, you are going to cross the NUMA boundary. But there's a concept called virtual NUMA that we have. If you tell the OS and the database that you are using virtual NUMA, it will be careful enough to take that into account and reduce the potential loss in performance due to NUMA boundary crossings. So we take all that, and you look at, we have a lot of modules here, so we take all those modules and we come up with cluster sizing. And then you have a database cluster, which is n+1 because you want to minimize the licensing cost for Oracle. And in the case of the app cluster, it's n+2 because there's no licensing impact by having more nodes. And the customer wanted a lot of headroom to add more app servers as and when needed.
Mohan, can I that just reaffirms what I said before. In this example, it's 1 vCPU to 1 core. In this case, I don't think the customer had hyperthreading enabled. But
yeah, we are assuming that it's only one vCPU per core.
And the reason we do that is if it is hyperthreading is enabled and you start adding more vCPUs beyond the number of cores, the SAPs rating per vCPU changes. So that's why we go for a 1-to-1 mapping, because we know then what the numbers are. SAPs per vCPU is the same as SAPs per core. So that gives us the starting point for a kind of a pretty good estimate.
And you have, because by doing that, you're actually having the 24% as headroom for the future.
Right.
So I just wanted to talk about one more aspect, which is the storage design. Most of the SAP virtualization projects If they fail due to storage design. So that's because customers or the VI admins are used to consolidating the storage as well, and here we have to be careful. When you consolidate a business critical app, you have to design just like you do physical. Very important. So if you have separate areas for data, logs, binaries, in physical, you have to have the same here. It does mean that your VI environment is going to become more complex. You're going to have a lot more LUNs to deal with. But when you're talking about a business critical app, and you want your database to perform as good or better than in the current state, you want to make sure that you follow this. And also one more aspect here is that we have multiple SCSI adapters. We've done in our labs, when we separate the traffic across multiple, they're all actually going to the same HBAs, but still, when you have multiple virtual SCSI adapters, you get more throughput out of it.
Yeah, I just wanted to add to that, like Mohan said, typical SAP environments you end up with a lot of LUNs per database. And traditionally, some of the storage vendors will only allocate 30, 40 gigabyte LUNs. But now, over time, some of the basic LUN sizes they're recommending might go up to 256 gigs, or maybe even 500 gig per LUN, which will reduce the number of LUNs you need. But because, in this case, this is the ERP system for SAP. This is their main ERP product. And their schema includes about 20,000 tables. 20 to 30,000 tables are in the SAP schema, and depending on which module you use and which modules you activate determines the number of tables which tables you use. But if you end up using all the modules in that ERP system, all your data is going to be in the LUNs titled SAP data 1 to 6, and that's why that gets big. As more transactions get entered in the system, if you don't do archiving, those LUNs will start increasing.
And one more thing that we always get asked when we go on consulting engagements for virtualizing SAP is that I have this huge 5 terabyte database or 10 terabyte database. I'm backing it up currently. Will I have to change my backup mechanism? The answer is actually no, because most of these big storage vendors are now VASA compliant. What that means is change block tracking and other things work. And if you have some homegrown processes where you are, for example, in the case of Oracle, you're turning on hot backup mode and snapping your storage, that still will work. And we recommend not using VMware snapshots. We used to use the array-based technology. And most major storage vendors now support backups of VMFS. Before, there was another reason customers are asked to do RDMs. There's no reason to do RDMs anymore.
Okay, thanks. Talk about performance management, and I'm going to focus really more on the memory side because SAP is a huge memory hog. And so for those customers who said for those of you who are running SAP now, be it production or non-production, are you using memory reservations? Because SAP is big on saying for SAP set reservations. That's why we had this reservation. I mean, this is for reserved seating, but they're big on reservations. So we also recommend, that's also a VMware best practice, set memory reservations for SAP and the database, the app tier and the database. The trouble is, of course, if you set a reservation, it reduces your consolidation. It can impact your VMware HA and your DRS or vMotion, because if you want to move a VM from one box to another box, if that amount of reserved memory is not there, available, you cannot vMotion. Now, for example, a typical app server building block might be a 4-way virtual machine. In a sizing scenario, we might estimate between 4 to 10 gigabytes per virtual CPU for that app server. That's somewhere between 20 to 40 gigabyte VM, which you're going to set a reservation on. Now, again, that's an estimate. Once you go live, you need to monitor it. And then, so what's important is you need to right-size the memory. But typically, before you go live, it's tough to do. So you have to wait till you go live and monitor it. So another thing, and one of the reasons that memory can be so high is because I talked about at the beginning, there's an ABAP stack and a Java stack. Depending on how you run SAP, if you run SAP the traditional way and you're using SAP GUI, you probably only have ABAP running in that VM. But in some of the early implementations, some customers may think they need Java as well in that same VM, so the memory requirement goes up. So that's another good thing to look at when you're doing a design. Am I running ABAP or Java? If you don't know and you assume both are running, your memory requirement might go up to 10 gig per vCPU. But if you're only running ABAP inside that VM, you can drop it down to maybe 5 gig per vCPU. And again, these are estimates we use in a pre-sales sizing scenario, and we typically do that with the hardware vendor. The hardware vendors have a sizing practice that we work with.
Yeah, one thing I want to add is a lot of times these requirements come to you from, memory requirements come from the basis team. So just follow what they're asking
right.
you.
So one of the problems we've seen from customers is you've got high memory, it limits your consolidation. You can only pack a limited number of VMs on your ESX server, and if you don't have high-density DIMMs, you end up with a few VMs and low utilization because you don't low CPU utilization. So obviously, having high-density DIMMs in your ESX host might help you a lot with big memory VMs. The other issue we've seen is this has come back from a few customers in the field. They've said, okay, we've got these huge-sized VMs. We're monitoring in production. And our VM ESX counters, the key one we tend to use is active memory counter. Tells you how much active memory a guest is using. That tends to show much less usage than the corresponding counter that the SAP admin sees. And in fact, the complaint they're saying, the issue they're seeing is all we see is spikes in the counter. So now I'm going to look at a bit more of how you monitor the memory of SAP in a VMware environment. So if we start looking at what's available, in order to understand memory, I want to explain first what's the memory structures look like inside an SAP app server in a virtual machine. This is a virtual machine running an SAP ABAP application server. So there's memory allocated to the OS. There's another memory structure SAP has, which is very specific to SAP. It's called the SAP Buffers. And that can be quite huge. Say, I have a 16 gig VM. Those buffers might be set to 1 to 2 gig, maybe a bit more. And the reason is SAP likes to buffer a lot of data in the app server tier to minimize access to the database. One example is if you're running sales order entry, you have pricing conditions. All that pricing data is static. It doesn't change. So on startup, SAP loads all that data into the buffer. And that's there. So every time you do a sales order create, you don't have to go to the database to find out what your pricing conditions are. You just read it from the buffer on the app server. And that's useful because if you've got a 3-tier environment, less hits to the database means less workload on the database and less network I/O from the app server to the database. Trouble is, that SAP buffer is quite static. I think ESX active memory counter may not accurately reflect the buffers. There are some other memory structures which is quite useful, is the heap and extended memory. And again, you don't have to understand the details of this, but what you need to know is, as a business user uses memory, as they run a transaction, they first get allocated extended memory. And if they exceed a certain limit in extended memory, they get allocated heap. Now, monitoring heap and extended is a good way of monitoring the business workload, a measure of how much memory you're using. Now, active memory counter from ESX may be able to measure heap and extended. Now, SAP have their own tools to manage this usage. And the beauty is that using those tools do not change in the VMware environment. You still use them the same way. So if you have a look at the counters now, this is like showing you, from a memory monitoring perspective, the VMware admin, of course, gets access to vCenter, and the ESX top, you get to see all the traditional memory counters that you're normally used to on the ESX side. And the one I'm going to focus on is the active memory counter. Now, what does the SAP admin see? Now, SAP, because of a partnership with VMware, SAP have created an API inside their own transaction that pulls virtual counters from the guest OS via the guest SDK API. So if I'm running SAP in a VM, SAP will pull out the virtual counters inside of SAP, and then you can actually see those counters in the traditional SAP basis transaction, which is a screenshot on the right. That's referred to as OS07N. These are standard transactions for SAP admins. But the island for the SAP admin is looking a bit better because they have access to their traditional counters to monitor the heap and extended memory, which I talked about in the previous slide. But they now have the ability to look at ESX active memory usage as well, and they can correlate the two. Unfortunately, from the VMware admin side, you don't have access to see what the SAP admin is seeing. But we're going to come to that. vCenter Operations will help you on that, and that's where I'm going towards. So to give you a better understanding on how these counters interact, I did an example workload in a lab to show how extended memory and heap usage, which are the SAP counters, how they correlate to ESX active memory. And this is the example I ran. I have an app server, just an app server. It's a 16-gig app server running ABAP. And this is what I did. I ran a custom, an SAP report. It loads data into memory. I see that data on the GUI, and I just stare at it for 3 minutes, and then I exit the transaction. And I have two graphs. The blue is telling me the memory SAP is using. So as I run the transaction, you can see on the blue, SAP starts utilizing the memory, and then it flatlines. That's the 3 minutes or so I'm just staring at the report. And then I exit the transaction, and the memory allocation SAP drops back down to not zero. There's some basic memory SAP needs, even when no one's using the system. What's the corresponding ESX active memory counter saying? That's kind of pretty good. It's in line with SAP memory. It goes up. In fact, it goes up a bit above the SAP memory counter because I'm not monitoring every SAP memory structure, just the two big important ones. So that's probably why ESX active memory is a bit higher. But the key thing to note is this here, the circle here. The worrying thing, well, not necessarily worrying, the issue here is that the ESX active memory counter drops before the SAP one, just slightly. And the reason is SAP users tend not to constantly run transactions. They will run a transaction, load it into memory, stare at it for a while, and they might even leave it in memory and then go off for a meeting. During that time, that transaction's there, ESX active counter is saying, well, it hasn't been recently touched, so it's dropping down towards zero. But the SAP counter is still saying, no, it's allocated and it's being used by the user, even though the user's just looking at the screen or just gone off to a meeting. That explains why you will see customers in production will tend to see that the ESX counters tend to just spike. All they see is spikes. Of course, you see the first spike when you start up the app server, memory gets allocated, then it comes down to zero. When then all the users log on, you see another spike. But if those users that log on start entering transactions every 3-4 minutes, that spike, it will be a spike again. Meanwhile, the SAP counter is the one that's more smooth. It flatlines and gives you a better idea of what's going on inside of SAP. So the conclusion to this is, what we're saying is, if you want to do capacity management of SAP, you can still use our tools, capacity management tool, but you should use our counters as a starting point, and you should then work with the SAP team to find out what's going on inside of SAP to make an accurate capacity management prediction. Again, it's tough to do if you don't have access to the counters, and if you can correlate them this way, this is one example I did using the counters inside of SAP, and I can only do this because SAP had the API that presented this counter, the ESX counter inside of SAP. But in order for you to do it as a VM, from a VMware standpoint, if you look at vCenter Operations, that would be the way to do it. So vCenter Operations, that's our performance management tool for performance analysis, predictive analysis. Out of the box, it'll give you all the virtual counters, which you can then trend. But the beauty of VCOps, it has adapters. If you buy the enterprise version, they have adapters to SAP, Oracle, SQL Server, I think maybe even the Java. Hyperic's included there as well. So through Hyperic, you can see Java counters. This is an example of the SAP adapter. So our latest release of vCenter Operations, it's a vApp appliance, 2 virtual machines running SUSE. And if there's a document, it's down there. You can pull it down from this URL. It tells you how to configure the adapter so you can pull in the performance monitoring data from inside SAP into VCOps. And basically, you download the standard, it's an API you download from SAP website. Now, the API that SAP provide that's documented here, It's their standard API to retrieve data. So you're following SAP standards. This follows SAP-endorsed standards to extract data from SAP. What needs to happen is the VMware admin needs to work with the SAP admin to get this to work. Both of you need to work together because you'll need access. The SAP admin needs to download the API, and then the VMware admin needs to then install the API inside the VM. The key thing is you also need a credential. You need a user ID to log in, and that's what VCOps needs whenever it does a collection run. You can configure VCOps to say collect data every 1 minute, 2 minutes, and then the user ID you get from the SAP admin, again, it's a special user ID. It's called an RFC ID, a remote function call. And the beauty of that is it can't be misused by the VMware admin. You can't use that user ID to log into SAP. So it's following, it's in compliance with SAP security standards as well. So this, if you do this, the advantage of this now is you can now see all the performance data inside of VCOps, the SAP data. And here's a screenshot giving that example. This is the adapter screen of VCOps. And over here, these are all the SAP performance counters, including the memory ones. They're at the bottom. Right here, extended memory, heap memory. And you can actually, you can see your own graph. So the idea is, especially if you're in an environment where maybe the SAP admin doesn't want to give the VMware admin access to SAP and vice versa. Maybe the VMware admin doesn't want to give the SAP admin access to vCenter. Use VCOps. That could be the tool where you can both work together to correlate memory. In the example I focused on was more on memory management. And the idea is once it's in VCOps, you can create a custom dashboard to pull together the counters you're interested, the memory counters, and compare that with the corresponding ESX memory counter. So if you want to see how ESX active guest is being used, compare that to the corresponding SAP one to give you a real idea of what's going on. And then you can calibrate it yourself depending on your own workload. So, and that adapter has been around for about 6 months now. Okay, just going to round up the topic on performance management. We talked about hyperthreading at the beginning, and we talked about how we ignore the 25% benefit of hyperthreading. We say that's a conservative reason, but there's another reason why it's okay to ignore it. OLTP transactions will benefit with hyperthreading by 25%, but a lot of the very resource-intensive batch jobs in SAP are things like MRP runs, material requirement planning. These are heavy supply chain management type batch jobs that get run on the ABAP side, and they're single-threaded in nature. So they may not take advantage of hyperthreading. And SAP have documented that. SAP have got a concept that they've called the single computing unit of performance. It's documented in an SAP note in their knowledge base. You can ask your SAP admin to pull it down. What SAP is saying is that they've introduced another KPI, another key performance indicator, which is the ability to measure how much hyperthreading will impact a certain process in SAP. And the idea is, what SAP is saying is, some of our workloads are single-threaded by design. Some of our batch jobs, long-running reports, they're single-threaded, and they rely on the performance of a single unit, like a thread or a core. So even though if I have multiple threads, this job is not going to take advantage of it. What's more important for them is that the clock speed. What we've noticed in the last 5 years as hardware vendors, they're packing more cores into a socket. As they do that, you get better throughput. You can scale horizontally, but the clock speed's going down. The performance of these batch jobs depend on the clock speed. They tend to depend on the clock speed. So what it means is if you're running SAP batch jobs in a hyper-threaded environment, and SAP has identified them as being single-threaded, you might want to, it's ideal if the vCPU that job is running is scheduled exclusively on the core. And the way you can do that in VMware is you set that setting, hyper-threaded core sharing, to none. That's a setting on the VM you do. What that means is if the VM that's running that single-threaded batch job is running in that VM with that parameter set, that VM is always scheduled such that the vCPUs of that VM is always exclusively on the core. It might bump off another VM, But again, you would only use that in a special use case. You need to identify the batch job that is single-threaded, that SAP says is single-threaded, which you can do with your SAP admin. And then it depends on your environment. If you're running in a, if you're not running with too much overcommitment, you may not need to set it. But a lot of customers are mixing batch with OLTP. They've got the batch running at night, and the OLTP is trying to kicking in the morning. And what happens is there's a point where sometimes the batch job runs too long, and then the OLTP VMs start kicking in the morning, and there's a short period where they're overlapping. In that short period of overlap, you want to give the batch job priority. So that's when you would set hyperthreaded core sharing to none, just for that time when you're running with high VCP overcommitment. Maybe your ESX utilization is high, and you have a priority on the batch job. So you really want to meet those three conditions before setting the, that option. It's not something you do by default. You just have to look at your special use case. The reason is, if for some reason you're not running your ESX host at 90%, say if it's running at, say, 60%, then it won't matter. You have enough CPU cycles for that job to finish without setting that parameter. So
I just wanted to add that if you follow the paradigm of one vCPU per core, then this would not be a problem.
So by default, when we do the design, that just backs up our original initial design, one vCPU to a core. But we know that once you go live, customers like to consolidate more VMs on the box. So even though they might have the memory reservation set, customers are running with VCP overcommit. Because the reality is, some of those VMs are mutually exclusive. To get better utilization, customers are running with VCP overcommit. So we've got three minutes left. We just added a few more topics in this repeat session we didn't cover before because I think they came up in the Q&A, so we decided to bring them up. I'm going to talk about 2 slides, high availability and then DR, and then we can open up for questions. And let me look at high availability. So VMware HA is our high availability solution out the box. So what that gives us from an SAP standpoint is it gives us automatic hardware monitoring. And that's one of the big reasons SAP customers are virtualizing. They want to get very simple and efficient high availability without minimal configuration. VMware HA gives that. SAP architecture has 2 big single points of failure, the database, and there's another component called the central instance. It runs locking and messaging. If either of those 2 goes down, the whole of the SAP system is down. So some customers, they've been used to monitoring those single points of failure using clustering software because they want application-aware detection. VMware HA doesn't provide that, so the third column is no. And also, because ours is not a cluster solution, we can't do rolling patch upgrades of the OS. Clustering solutions tend to offer that. So traditionally, customers have been protecting SAP in the physical world with third-party clustering software, like RAC, Oracle Clusterware, Veritas Cluster, Sun Cluster. Those are the kind of the clustering solutions SAP customers are using. And some customers are saying, look, VMware HA is great, but I really need software monitoring as well. I need automatic detection of my database and central instance. So the one solution we can offer is, okay, it's a complex solution. You can run clustering software inside of virtual machines. So we've got a few customers who are willing to run Microsoft cluster inside of virtual machines. And the downside of that is you can't vMotion, and it's a more complex. If you're using RDMs physical, some customers might have got it to work with vMotion, I'm not sure, but officially, our documentation says you need RDM physical mode for Microsoft clusters, so you can't vMotion. I've heard cases where customers have managed to bypass that. But I'll let those customers speak up if they have done it. But recently, you've got Linux clustering. A lot of customers running on Linux. You want to run Linux clustering out of the box? Linux clustering works with virtual machines, and it supports vMotion. So that's an option. Most of our customers are going with just VMware HA. This is the ease. They've got a few who might need the clustering. And so some customers said, give me an interim solution, which is not as complex as clustering, but gives me software monitoring. And that one we achieved we introduced VMware HA APIs. And that is the interim solution that's integrated with VMware HA and has soft application awareness. Basically, these vendors here they're using our VMware APIs to create SAP-aware clustering solutions that run inside the guest OS. So our partners are doing that. So if you're already working with one of those partners, that's probably another viable option.
Just wanted to add, you would see the cost complexity on the right. So if you look at the bottom, it's high because, first of all, you're running a cluster inside a cluster. And the second one, the cost is also very high because in that model, you have a standby sitting there doing nothing. So you're going to have, you have to size your cluster double the size.
Yeah, and it's high because you still need to have cluster skills, specialized cluster skills. So a lot of the final solution kind of does depend on the customer. A lot of customers have told us they've gone live and they're going with VMware HA. That gives them the uptime they need. They don't need software monitoring because in their mind, they've never had an outage which wasn't related to hardware. Every time they had an outage, it was because the hardware failed. VMware HA gives you that. They've told us, look, those single points of failure, the software single points of failure in SAP are very robust now. They don't fail on their own. That's some customers. Other customers will give a different story. Then other customers will give the story, we've used clustering, but we've had problems with clustering, and clustering itself gives more downtime. So that's why they've opted for the VMware HA only option.
Yeah,
and some now are looking into the middle one. Now.
Yeah, I personally was a Unix admin for like 16 years. So a lot of the problems were clustering was the clustering software itself, and the operators not knowing what to do, and things breaking because of that. So like Miami-Dade is an example where they're just using VMware HA and very happy with it.
Okay. Just got a couple of minutes left, one slide, and it's on DR.
So we just wanted to wrap it up with DR. DR is a very big topic. For SAP, SRM can be used, but we have a lot of scenarios that we can use. vSphere application, for example, can be used at the app tier because there's no data there. So the 20-minute RPO would not impact it. And at the database layer, there are two options that we have. One is like the traditional option where the storage array replication. But storage array replication can be very expensive because the storage array vendor charges a lot. So there are also traditional options where you have log shipping, like DataGuard, or you can combine log shipping and vSphere replication to actually have an SRM-based DR solution. And there was a talk yesterday about how you could use DB log shipping with Oracle DataGuard, and then you can actually, if your company already has DBAs that are familiar with DataGuard, you can combine the two. But it's just that when you use DB log shipping, it's a little bit more complex. There are a lot of homegrown scripts you have to use, but it still can be done.
Yeah, I think that's it. Just a quick summary of what we talked about. It's supported, and the key thing is on the design side, we will work with the storage vendor and the hardware vendor for a virtual design, because all our vendors have their own SAP practice dedicated, and they've been doing this for 15 years. That's why we work with them. And performance management, VCOps is a great tool if you want to bring all the data together in one place. And hyperthreading is useful, but not in every use case depending on the type of workload you're running, like batch jobs. And we just talked about DR and high availability. Any questions? Thank you. Yep, gentleman at the back. Middle. Yeah, good point, and I forgot to mention it. So the question was about fault tolerance. How does that fit with SAP? I mentioned the single point of failure, the central instance. It does message and locking. That is a component that you could put in a VM under fault tolerance. But fault tolerance limitation is one virtual CPU. The central instance, the locking and messaging, all that is, it's just a shared memory lock. It's not that CPU intensive. And that happens every time you create a transaction or change a document in SAP, it grabs a lock. And that lock is in shared memory on that CI server. You could probably run CI in FT and probably run up to 1,000 concurrent users, and that VM will probably be at less than 50% utilization. So that's an option. Some customers are doing that, and in fact, they spoke here. Yeah. Joanne Fabric was speaking about their SAP implementation yesterday. They're doing that. They're putting the CI in a VM under fault tolerance, so they don't need clustering software at all. So other customers are saying, we do like that solution, but they're a bit nervous about the one vCPU limit. Even though they know they can probably run that service within one vCPU on a fast core. They might have some sort of compliance reason internally that says minimum size of an SAP VM is 2 virtual CPU. So that's a problem for those customers. So it is a viable solution, but it kind of depends, again, on individual customer requirements. Yep.
Are most of your customers having dedicated clusters for SAP environments?
Yes. So one of the things that when we do business critical apps, we recommend the customers not mix with their traditional clusters. So you want to dedicate your clusters and grow them as you go. So, and particularly as I showed earlier in the example, licensing also there's an impact. So you want to be careful there.
Any other questions? Yeah. SAP and vMotion, okay, and from a lab standpoint, no problems there. In terms of the question was experience of SAP and vMotion in an ERP environment. Sorry? Yeah, ECC. Customers are doing it. The question is, I think, with the huge memory requirement, you're probably asking to say, what's the biggest VM that we vMotioned? I don't know. We vMotioned I've seen 64 gig Oracle database running SAP vMotion fine. SAP internally are vMotioning huge systems inside of SAP. So it's working fine. Of course, with the bigger memory you get, you do want to spend on the infrastructure for the, was it at least a minimum? Could you go with 10 gig
pipes, and then also, obviously, the time is going to be longer for the bigger VMs. The time it takes, but not the switchover time, not the actual cutover where you lose a ping. Usually, is a ping you lose, but the time of the vMotion itself could be longer, the total duration.
Right. In fact, databases, I haven't seen the problem. We've done it with database. App servers, it depends how the rate of change of memory on the app server. So it depends what it's doing. That will impact how long that vMotion occurs. But we are doing it, and customers are doing it with no problem.
And we have had a lot of improvement in vMotion from 4.0, 4.1, 5.0, 5.1. So a lot of the issues are gone.
Right. There is a paper on Rack that shows you a different. Or are you saying they're doing a table lock by the vMotion? Yeah, they're doing that. It should only be.
No, it doesn't. No, the process is stopped only during the actual switchover, which is 1 second. It's not the duration of the vMotion, because everything you're doing is continuing on the box and it's being replicated. So.
But are you saying you've seen some problems? Maybe. Yeah, try with 5, but if you are seeing noticeable functional issues with the app, maybe some that immediate SR, log an SR with our support desk, because they know how to debug vMotion. Sometimes it could be a network setting. Is it on Microsoft by any chance? No, it's not. Okay. Log an SR. Although I haven't seen any problems, customers are doing it. Right, just for that, is it temporary though? It's a blip, and then it. Right. Okay. Okay.
So personally, I had worked at eBay, and then for Java-based servers, they had issues in 4.0, not in 4.1 onwards. It's all disappeared. And only thing we would actually do is like limit the number of vMotions happening at the same time. Yeah. There's a setting at the cluster level you can do that. So
but like you said, if 5.0 is even better.
Yeah.
5.0 will probably, yeah. We saw a noticeable difference with Oracle when we went from 4 to 5. Any other questions?
Granger.
Yeah. Yeah. From the SAPs. Yeah. I don't. SAPs value.
Lockheed Martin is looking at it, so it's starting.
From the SAPs, we're seeing. We've got customers in 100,000 SAPs who virtualize maybe the app tier.
That's Granger.
Yeah, and then on the database tier, I've only seen, it's a recent one, the 20-way virtual CPU database. That's around 60, even more than 60,000 SAPs just on the database alone that was virtualized. Yeah.
Any other questions?
We're just in the process of ordering
Oh,
just the app.
for the app tier. Okay. Million, wow. And virtualize that on the app tiers, and if it's oversized, drop the VM if you don't need it. Yeah. I mean, on the app tier, we are seeing a lot of big customers. I'll mention them because they actually presented, so they went public. Dow Chemical, they virtualized the app tier 2-3 years ago. Huge amount of SAPs. I don't know the exact number. Their database was mainframe anyway, but their app tier was huge. Every app tier virtualized. So definitely on the app tier is not a problem. Just keep scaling out horizontally. Any other questions? Well, great. Thank you for your time and your attention. Thank you.
Thank you.